So when we look at the principle of atom economy, the key question we have is how much of the products I produce are useful. Now, this is a really important question that people who are undergoing chemical reactions, especially in industry when producing products that they're going to then use or sell on, is how are we minimizing our waste? Okay, so I want you to imagine that I've got a reaction for A plus B forming C plus D. Okay, and let's imagine that C is our useful product and D is wasteful. Obviously, we want to make lots and lots and lots of C, and we want to make not very much of D. Now, we can use this equation to calculate atom economy, such that atom economy is equal to the relative formula mass, so of our desired product, divided by the relative formula mass of all reactants. Now, due to the law of the conservation of mass, we know that the total mass of the reactants is going to equal the total mass of the products. But by conventional speaking, we use the total mass, relative formula mass of the reactants when we're working out these calculations. So I'm going to give you an example now. So, example, hydrogen can be manufactured by reacting methane with steam. Okay, and that is according to this following equation here. CH4 plus H2O to form 3H2 plus carbon monoxide. Now, in some cases, you will be asked to balance the equation. Here, they've already balanced the equation for you. So I'm going to add here, in some cases, you will be asked to balance the equation. Now, something to note here as well that's really important is when calculating the MR here, okay, you do need to take account of the balancing numbers. Okay, and that is because when we're working out the atom economy, we need to work out how many moles of both reactants and products are involved in the equation. When we do a reacting mass calculation, we have that ratio step which accounts for this. So we don't use that when calculating the MR, whereas here, okay, we do need to take account of this. So using our equation then, the atom economy is essentially equal to the MR of 3 times H2 divided by the MR of CH4 and H2O. So that gives us atom economy is equal to 3 times 2 divided by 12 add 4, which would give us 16, add 2 plus 16, which gives us 18. So we essentially have 6 divided by 18 34. Which gives us 0.17. And again, this is expressed as a percentage. Okay, so I forgot to add in here, we need to times this by 100. So times 100. Okay, so when we get our answer here, we have 0.17 times 100, which gives us 17%. So only 17% of the products are useful. So if we then work out how much is wasted, so wasted is equal to 100 minus 17, which gives us 83%. Okay, that much is wasted, so that is a lot of waste in this reaction. So when we come to look at atom economy, you may be asked to compare different reaction routes to produce a particular product and judge which is best based on perhaps the one with the higher atom economy. So the higher the atom economy, the more useful product that is produced. And obviously the maximum atom economy that you could ever get would be 100%.